Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from application of derivatives under increasing and decreasing functions, right? So here we have to solve this problem which goes like this. Find the intervals in which the function f of x is equal to 2 tan inverse x minus 3 times log of x minus square root of x square plus 1 plus x is increasing and decreasing, right? So here we are given this function f of x which is a combination of inverse trigonometric function, the log function and the algebraic function, right, or the polynomial function. Okay, so here we have f of x. So this is inverse trigonometric function, this is log function, and this is a polynomial function, right? And we have to find in the intervals in which this function is increasing or decreasing. So for increasing and decreasing, what we do, we first try to find the derivative of f of x, right? So let us differentiate this function f of x with respect to x. So when we differentiate it, what we will get, here we will have 2, the derivative of tan inverse x is 1 over 1 plus x square, and here we have log of x minus square root of x square plus 1. So we have 1 over x minus square root of x square plus 1. The derivative of log x is 1 over x, right? And then by chain rule we'll differentiate this term, that is x minus square root of x square plus 1, and here the derivative of x is 1, right? Now we can write it like this: 2 over 1 plus x square, and here we have 3 over x minus square root of x square plus 1, and the derivative of x is 1. The derivative of square root of x square plus 1 is 1 over 2 times square root of x square plus 1, and then by chain rule the derivative of x square plus 1 is 2x, right? And here we have 1, right? Okay, so now we can simplify it. 2 over 1 plus x square minus 3 over x minus square root of x square plus 1, and then here this 2 and 2 get cancelled, and we are left with square root of x square plus 1. So here multiplying this one by square root of x square plus 1, then we have here minus x divided by square root of x square plus 1, and here we have plus 1, right? Now here we see that this term x minus square root of x square plus 1 is same as this term except the negative sign. So we can write it like this: 2 over 1 plus x square, and from here we can take negative sign common. So we'll have minus 3 over x minus square root of x square plus 1, and we have minus x minus square root of x square plus 1 divided by square root of x square plus 1, and here we have this bracket, then we have plus 1, right? So now we can cancel out these two terms, and this negative and this negative becomes positive. So the derivative of f of x, it now becomes 2 over 1 plus x square, then we have plus, minus and minus becomes plus, we have 3 over square root of x square plus 1, and then we have plus 1, right? So the derivative of f of x is given by this expression, right? Okay, so now let us come to the definition of increasing and decreasing functions, right? Now we know that if we have a function y is equal to f of x, then this function is said to be increasing when the derivative, that is dy over dx, is greater than 0, right? So for increasing function, the derivative or the slope must be greater than 0, and for decreasing function, the derivative must be less than 0, right? So here if we take this f of x as y, then here we have dy over dx, right? So now if we look at this expression, then we see that the derivative, it consists of three terms, right? So the first term is obviously a positive term for all values of x, because here we have x square, right? So 2 over 1 plus x square is positive for all x, right, belonging to R. And then the second term, 3 over square root of x square plus 1, is again a positive term for all values of x belonging to R. Why? Because here we have square root of x square plus 1, and this x square term, it is always positive, right? And 1 being a constant, it remains as such. So we have f dash of x is equal to positive. Here we have positive term, then we have again a positive term, and then we have 1 which is also a positive term, right? And the combination of all these three positive terms is again a positive term, right? So we see that the derivative of this function is always greater than 0 for all values of x belonging to R, right? So here x belongs to the interval minus infinity to infinity, right? So this function is increasing in this interval, that is from minus infinity to infinity, and here all the values of x are covered in the entire real number line, right? So there is no question of this function being decreasing, right? So the function will not decrease in any of the intervals, whereas this function is always increasing in the interval minus infinity to infinity. So finally we can say that this function is increasing for all x belonging to R, and there is no interval in which this function is decreasing. So here we will have no interval for which this function is increasing, right? So this is how we solve this problem.